We would like to show how CATIA visual scripting and the template approach can speed up and automate some steps of the modeling process. For this demonstration, we start the concept design of a new seat with CATIA Creative Design Experience, our brand new subdivision modeling application. We create simple surfaces without any details. Then we switch to CATIA visual scripting application. And we use the initial surface as our design sequence input. This surface is converted as a quad mesh. And we use mesh modeling and soft body operators to operate and deform it with physics behaviors. From a simple list of constraints and parameters representing pressure or elasticity, we are able to deform the initial mesh. The idea here is to get some details and bumps on the surface, such as real leather material. With this approach, it's quite easy to rapidly iterate and find the best mesh deformation. Finally, the mesh can be converted and published as a new subdivision surface, to be used or edited in other applications. A second algorithm is created to automatically split the model into multiple parts, from a simple list of curves. We use again mesh modeling operators to automatically rework and add details where the parts are connected. New operators are used to add edge loops and faces from boundaries of the mesh. Here again, the objective is to quickly add some details for the sewing area, where the leather parts are joined. Different colors are automatically applied to better visualize the result of the parting process. In parallel, a third algorithm is created on a sample model, to automatically generate stitches from a simple curve. With basic geometrical operators, we are able to create prismatic shapes from points, planes and segments of the initial curve. We create a mesh from faces of the prismatic shapes, and we use mesh subdivision operation to smooth them. This simple technique is interesting to represent a first level of 3D stitches with a low cost of computation. Some parameters are defined for the length, the step and the diameter of the stitches. Then, we create a new power copy from the design sequence, to be able to retrieve and reinstantiate it for other projects, as a modeling template. We start the command to instantiate a power copy from the database. And we retrieve the sample model containing the power copy. A dedicated interface is here to select the right geometrical inputs and change parameters for the instantiation. Stitches are generated in few seconds on all input curves. Finally, we have 3 different power copies from the different algorithms, to reuse and apply them on the other initial surfaces. Now, we switch to CATIA Live Rendering application, to create and apply materials on the reference model. And we use ray tracing to compute realistic renderings, without any data preparation or export and import process. CATIA visual scripting offers additional interesting capabilities to prepare some outputs for the manufacturing process. It is possible to automatically unfold all parts of leather or fabric. And we take benefit of the nesting capabilities to find the optimized layout of the parts, minimizing the raw material waste. We also use the virtual mannequin of CATIA Human Design to assess our current design, and identify potential issues during the concept modeling phase. After any change on the initial surfaces, all templates are regenerated thanks to the CATIA associativity. A great benefit of CATIA visual scripting is to create algorithms generating results from inputs and parameters. It allows more design iterations in less time. And the template approach can definitely speed up any traditional modeling process, and reach a high level of details even at concept and creative design phase.